13.1 Tangent ratio. The essential question: how do you find the tangent ratio for an acute angle? So, basically, this is the introduction of trigonometry, and you'll apply this later, not just in geometry, but also in Algebra 2, pre calculus, most definitely, and then calculus, and even further. It's pretty extensive into the rest of mathematics. So let's stay focused on, first off, the tangent ratio. Now, what does that mean? Our answer here for our essential question is for an acute angle in a right triangle. So again, 90 degrees, got to have the 90 degrees. All right, if we don't have a 90 degrees, it's going to be a little different. All right, now the tangent ratio is the ratio of the length of the opposite length. Okay, so that's the key word, opposite length, to the length of the adjacent leg. All right, so tangent is basically the opposite over the adjacent. So basically, it's like this. Um, let's say you wanted to find the tangent ratio for A. Okay, so this is kind of an example. First things first is who's on the opposite side of angle A, and that would be BC. Okay, so BC would be the opposite leg. Now, who's going to be right next door? That's the adjacent. Okay, so basically, tangent of angle A, or vertex A, is going to equal BC over AC, which is really just opposite over adjacent. So again, tangent, you should think opposite over the adjacent. And again, adjacent is just a fancy way of saying the next door neighbor. Now, I know you're probably just like, oh, Mr. Webb, what about AB? Well, that's the hypotenuse. Okay, so there's going to be three different descriptors for line segments. You either have the opposite or the adjacent or the hypotenuse, and it's always in reference to whatever your reference angle is. In this case, your reference angle um, is angle A. All right, so let's take a look. Now, the definition: the tangent of an acute angle A, okay, and that's going off the previous image, written as tangent of angle A, is defined as the following. So, tangent of angle A is the length of the opposite, okay, of angle A over the length of the adjacent to angle A. Okay, so again, basically, I'm just saying opposite over adjacent. All right, and that's all the tangent ratio means. So again, tangent of measure A or angle A. There we go, angle A. All right, so example one. This is very much calculator heavy until you start to memorize your properties and ratios of special right triangles. So basically, it's this tangent ratio for angle A. So again, our reference angle is here at A. All right, so the tangent of A equals the opposite over the adjacent, which equals, let's see, our opposite. Who's on the opposite side of angle A? That's BC. And then our adjacent, again, our next door neighbor, is AC. Now, for values, you would say, well, BC is 18, they gave that to us, over our adjacent, which is AC, which is 24. And you can actually reduce, if you wanted to, you could reduce, we could try, I believe, by 3. So reduce by 3, and you should get that. I can reduce even more by 2, and that. So really, tangent of angle A should equal you 3/4 or 18 over 4. So that is the answer for the tangent ratio. All right, so tangent ratio for angle B. So I'm going to use a different color here just to make sure we don't trip up here. So again, we're going off of this angle. So this is now our new reference angle. Okay, so again, tangent of angle B really just equals, again, opposite. So who's on the opposite? That'll be AC over my adjacent, which again is BC, because AB is going to be both the hypotenuse. The hypotenuse is always going to be on the opposite side of your 90-degree angle. So that's like a fun fact right there. All right, and AC was again 24. They gave us a numerical value, and BC was 18. You could reduce, and if you reduce, you should get 4/3. So the tangent of angle B equals 4/3. Now, this is a question that I want you to answer below, okay, in a sentence. What do you guys notice about the relationship between the tangents of angle A and angle B for their ratios? What do you guys notice about them? All right, and then think about why. All right, so just kind of keep that back and think why does it look that way? All right, so ponder that. All right, so your turn number one. Find the tangent ratio for angle Q. Okay, so that's the reference angle for the first one, and then angle R, and that's the one right here for your reference. All right, so try those out. All right, so this is where trig really does kick in with real life application. Now houses, you could probably measure the height of a house just fine with a pretty long stretch of rope or really large measuring tape. But sometimes you can actually use indirect measurement with trig to find heights of buildings. Even your phone has an app you can download, and it'll actually give you angles and stuff like that of whatever object you're aiming at. It's pretty cool. So we'll play with that later. But basically, in order to satisfy safety guidelines, a contractor determines that she must place the base of her ladder 6 feet, okay, 6 feet away from her house, okay. So we got 6 feet away from her house, and then she makes a 76-degree angle with the ground. So she probably like looks up with her phone, and her phone reads out, she aims at the roof. So here's the top of the roof, okay, and then she aims, and her phone gives her 76 degrees. All right, and your phones can actually do that. It's pretty cool. Now, to the nearest tenth of a foot, how far above the ground is the eave of the roof? Oh, so this is the eave of her roof. Okay, so basically, all you have to do is, well, you have 76 degrees from this angle. That's your reference angle. So tangent of angle A should equal your opposite over your adjacent, right? And basically, angle A, they already gave us the measurement. That measurement was 76 degrees. And it should equal the opposite, which is BC, which we don't know what that height is, and that's actually what we're solving for, over our adjacent. So again, our opposite is the height of the eave, and our adjacent is the 6 feet that she stepped away from, which is AB. So we're going to go ahead and work with the quantities now. We have tangent of 76 degrees equaling BC, which I'll just refer to as X because we're looking for it. And then AB is 6 feet. Now let's isolate X. How do you get rid of a dividing 6? You multiply what you do to one side, you do to the other, so you get X equals X equals 6 times the tangent of 76 degrees. So in your calculator, you would actually type 76 degrees. All right, I'm doing this verbally. You're going to type 76 degrees or just 76. Press tangent, and you should get 4.010780934, right? And then you're going to press multiply by that 6, and you should get approximately 24.06, and this is feet. So there you go. So basically, without climbing up the ladder or getting a huge, rope or measuring tape to try to get up to the top of that house, this lady was able to take a couple steps back, 6 feet steps back, measure with her phone the angle for where the eave was, and just by using good old fashioned trig, she got her approximation on how high up her eave was. Good to know, especially if you're going to go buy a ladder and you buy a 20-foot ladder and you're just like, oops, you know, I needed a longer ladder. So that's something to consider in real world. All right, so definition. Now, if you are given the leg measures and want to find the measures of the acute angles, then you use the inverse tangent of A. And this is read as the inverse tangent of angle A. So, tangent to the -1 is the inverse tangent. Okay, to find the angle. Now, why is that useful? Maybe you have to, buy a certain angle support for wood beams or even just welding to make sure your angle's okay, and you would use this kind of math. So let me explain. So in example two, if you notice, they already give us the angle, or not the angles, the sides, all right? And we're going to find the measure of angle A and angle B using the inverse tangent. Now, first with A, okay, because we got to find them. We don't know the angle, but we're going to, all right? We do know that tangent of A is going to be the opposite over the adjacent. So again, tangent of A should equal 20, which is our opposite, over 10, which is really just 2. You could reduce. Now, this is what's crazy is to get rid of the tangent of A, you have to use the inverse tangent. But what you do to one side, you have to do to the other. So this is actually all you have to type in. It's actually kind of nice. It's not that bad. All you have to do in your calculator is type in 20 over 10, or just 2, and then press second inverse tangent. So basically, it's like you'll see tangent, but once you press second, you'll be hitting the inverse. So really, you're just doing this in your calculator, and what you should get, and I'll go ahead and type it in my calculator real quick. Here we go, inverse tangent. There we go. Okay, so you should get approximately 63.43, and that's degrees, because don't forget, we're actually finding the measure for angle A. All right, now for measure B, again, reference angle's different. So let's change my color scheme. There's B. All right, opposite over the adjacent. Okay, so tangent of B is really just going to be 10 over 20, or 1/2. Now, in your calculator, all you really have to do is 10 over 20, or 1 over 2, and then just press the inverse tangent button. And that should get you your degree. So my calculator is slightly different, so excuse me while I kind of reverse my thoughts here. There we go. Your calculators work slightly differently on how you plug things in. Okay, there we go. And you should get approximately, if you do this correctly in your calculator, 26.56 5. I could actually round up. In fact, I'll round up just because I want you to see what I see. Do you see what I see? There we go. All right, so the measure for angle B is approximately, sorry, equals, not approximately 26.56 degrees. Now, down here below, just write a sentence, okay, of what you noticed the relationship is between angle B and the measure of angle A. What is their relationship? They have something in common. They have something that, when together, there's a pattern, or it's always like this. Okay. So, what do you guys notice? And if you had that reflection back with the ratios, you'd probably start to see like the refined idea behind what our results have shown us. All right, so your turn number two, find the measure for angle A and angle B. Remember, this is with the inverse tangent because we already have the side lengths. We're just looking for the angle measurements. All right, so here's our homework, page 692 through 695, numbers 2 through 11, 15 through 17, and 22. Thank you guys, and have a great day.